Hello guys, welcome to this GenAI search video. So in this video, we are going to be watching how to use GenAI to search data from a database. And at last, we will be built this chatbot UI where we will be entering prompt and it will analyze the prompt and generate appropriate SQL query. And then we will be executing those SQL queries to the database and fetch the data and show up in this chat UI. So you will need latest Python installed in your computer, and we will be using a Postgres database where we will be storing some student related data like student name, their classes, subjects and test marks of the students for this project. And for the LLM, we will be using Grok latest 4.1 fast LLM, and you will need Grok API key which we will use to analyze this prompt and generate appropriate SQL queries. We will also use Panda to query the database and also show the data. And all the source code related to this project and future videos, you can get it in this GenAI and RAG repository. So let's get started. First, we will be setting our LLM keys and Postgres SQL database credential. So let's create .env file. So for this tutorial, we need to set up our database URL, and I am using my local Postgres database server, and I have already created a database called GenAI DB. And for the LLM model, I will be using Grok 4.1 LLM model. We need to provide the Grok API key and the Grok base URL. We will be using OpenAI Python library for calling this Grok API. So you need to sign up to this console.x.ai portal and create your own API key. Then you need to paste that API key on that env constant. So after setting all the constants, we need to create a Python virtual environment. So I have already installed latest Python, so we'll be using 3.12. Next, we need to create Python virtual environment. So Python -m venv, and our virtual environment will be venv. Now we need to activate the virtual environment. Source venv bin activate. Next, you can check if the Python is pointed to your local directory or not by typing which Python. So now you can check it. We are using our local Python path. Next, we will be installing UV. So pip install UV. So UV enable you to parallelly download pip packages. So that's why any installation of Python packages will be faster if you are using UV. So to use UV, you can just say UV pip install notebook. So we will be installing notebook because we will be coding all of our Python code inside Jupyter notebook. So as you can see, it's pretty fast. So next we will be installing VS Code notebook extension. So Jupyter. So I have already installed. It is from Microsoft. Now we can create Jupyter notebook inside VS Code. So let's create a folder notebook, and inside here we will be creating our Jupyter notebook. GenAI student.ipynb. So so in here you have three options: generate for AI generated code and markdown. So let's test this. Print if hello from GenAI. Control enter. Now we need to select our Python environment venv. So we are using local Python environment. Save it. Let's run it. So as you can see, our Python runtime environment is ready. So this will be our project architecture. So inside student schema table, we will have these columns. So first name, last name, gender, date of birth, age and class ID. That's mean every student belongs to one class. Then we will have a class table where we will have this name and status. Then we will have this subject, and each subject will belongs to only one class, and there will be a description of the subject. Next, there will be a test marks table where we will be storing all of our subject marks for each student. And this will be our relationship. Student belongs to only one class. One class have multiple subject. one class have multiple students, and one student has marks for every subject. And we will be using this kind of prompt in future. So like profile information, name John Doe, and also we are expecting class info and its subject and marks if exist. So from this prompt we can fetch all of the data from this database. But first we need to install some libraries. So we will be using scicog2 binary for Postgres connection, SQL Alchemy for creating the models. Then we will be using pandas for data visualization and database query, and python.env to load all of our environmental variable to this project, and OpenAI library for querying the LLM model. So let's install this. Because we are using UV, that's why it is pretty fast. So next we'll be importing some libraries from SQL Alchemy, and we will import pandas.env, and then we need to call this function load.env to load all the environmental variables to the runtime. So it's true, that's when everything is fine. Let's print the database URL. So as you can see, it is coming from our .env file GenAI. Next we will be building the table schema. So we are creating our Postgres connection. Then we are creating our class. Then we are creating our class model. This is the table name classes, and it has ID, name, and status. And these are the relationships like students. So class have many students. It will have many subjects, and it will have many marks. Then we have the student model. So it refers to the students table. So this is the class reference. So this is the class relationship, and every student will have multiple test marks for each subject it belongs to. Then we have the subject model. We have this name, description, and the class it belongs to, and these are the relationship, that is class and test mark. Next we have this test mark model. This refers to test mark table, where we have this ID, name, the class ID, student ID, subject ID, marks, and total marks. And these are the relationship class, student, subject. Then we will be dropping all the tables, and we will be dropping all the sequence for these tables if they are existed. And then we will be creating all the tables with the help of the Postgres database connection. Then we will be creating a session to query the database, and also creating the data. So let's run it. So all tables dropped and new table created. So let's go to the database. So as you can see, these are the 4 tables: classes, student, subject, and test marks. Then we will be populating some demo data. So we will be creating 3 classes, that is 5, 6, and 7. Then we will be creating 8 student for each classes. Let's create those. So it will be 24 student. Then we will be creating some subjects: math, physics, chemistry, biology, and geography. And for each class we will be creating different subject. So subject name will be like subject name, then the class name. For class 5 it will be math 5, physics 5, chemistry 5, and for class 6 it will be math 6, physics 6, and chemistry 6. So let's create those. So it will be 15 subjects. Then we will be creating marks for each of the subject for each student, and for marks total will be 100, and we are generating random number between 50 to 99. So let's create those marks. So our marks are created. So next we will be querying the database using panda. So pd.read SQL, then we will be providing our SQL. So let's see. So this is the table data, ID, name, and status, and these are the 3 classes. Next we will be fetching all the students from class 5. As you can see, these are the data. So now, rather than writing this SQL query manually, we will ask our LLM to generate this SQL query for us. Then we will be using this function to execute that SQL query to the database and fetch the appropriate data. So now with the help of GenAI, we can ask the AI model to generate SQL query for our resources and execute the query that we do, and we do not need to manually write SQL query for each table. This is very useful if you have n number of resources and just define the database schema to the LLM model and their relationship in the context, we can query anything. So let's see how we can do that. So first we need to import OpenAI from OpenAI, and we will be using JSON also to parse the response. And then we will be using this Grok API key and Grok base URL to create a API client for us. And then we will be using that API client and we will be passing our custom prompt and get the data as a JSON object. So in this API, we need to first define the model. So we are using Grok 4.1 fast reasoning model. So in this messages, we have a object consists of two attributes, that is role and content. So first role is system and content is you are a helpful assistant. So we are telling our LLM how to behave. Next will be role user and content, what is the capital of India. So next object is from the user and the prompt it is asking to the LLM model. And third parameter is response format. We can get the response as a text, but if you want to get the response as a JSON object, we can also define that in here. So let's try this. So as you can see, the response is as JSON. So it is answer New Delhi. So we asked for the capital of India. So our API client is working perfectly. Next, we will be creating a function named query database with AI, which will be accepting two parameters. One is our API client and next is our user prompt, which will call this API and pass our user question, and then it will create that SQL query and return the response as a JSON object. Then we will be extracting the SQL query from the response and execute to the database with the help of Panda. So let's do that. First, we need to provide the database schema to our LLM context. So we have provided the table name and their columns and the relationship between those tables. So student belongs to one class, subject belongs to one class, test marks belongs to student, class and subject. Okay, because it has class ID, student ID, subject ID. Then we are asking Grok to limit all of the SQL queries to 10,000 by default if no limit is specified in the user prompt. So next we are creating this function. We are passing client and users question. So in the prompt we are passing our schema information. This is our user question, and we are asking LLM to generate Postgres SQL query to answer this question. Return SQL query with no explanation. So in the system message, we are telling our LLM that you are a SQL expert. Generate only valid SQL Postgres SQL query in JSON format with a single key query. So in the return JSON object, in the query attribute, we will get our SQL query. And in the next object and in the next role user, we are passing our prompt, which include our schema information for the table and our user question. Then we are getting the user response and extracting SQL query from the query attribute. Then we are passing that SQL query to the panda.read SQL function, and we are returning the panda data frame. So let's test this function. So we are querying the student information of John because there is a John named student inside our database. So let's run this. So as you can see in the response, we are getting this JSON object. Then we are extracting our SQL query from this query attribute, and inside here this is the data. So in this SQL query we are getting all of the fields from the student, and we are also joining the class table also to get the class name. And you can see here where s.firstname is John, and by default it is limiting to 10,000. Let's try some complicated queries. So in this query, we are fetching student profile in class 5 who got highest mark in geography subject. So it's return the SQL query, but there is no data. So let's check the SQL query. So as you can see, it is querying subject name as geography. But in previously, if you remember, we append the class name also after the subject name. So it will be geography space 5 for class 5. So obviously LLM does not know that. So we need to tell our LLM that if there is a class name present in the prompt, just append that class name after the subject. Otherwise use like query. So we can define it inside our prompt. So in here we can also pass our custom instruction. So there is some exception that we are saying that when querying subject names in the database include the class name as a suffix, like math 5, physics 6. If the user asks about a subject with specify the class name, use the name subject then space class name. Example, in case of class 5 query, then we will be using where name is equal to math 5. And if user asks about the subject without specifying the class name, so that is the negative case, we will be using class name like math, then we will use like pattern matching to find all of the matching subject, like where name like math then percentage. So we are using like pattern. We need to also pass this custom instruction in the prompt. Let's rerun this block and try again, and let's try again. So as you can see, in this time we got a result. So if you check the SQL query, so we got the correct SQL query. So in case of class 5, we are using geography 5. So let's check if we don't provide the class name. Okay, so fetch top 5 student in class. So we'll remove the class 5 and let's see what will be happening. So here is the SQL query, and in here as you can see we are using like pattern because we don't provide our class information in the prompt. So in this way you can fine tune any query by changing the context, and if we provide correct context to the LLM, it can generate correct SQL query. So now we can see these are the top 5 student. So next we will be creating that chatbot UI that we have seen in the starting of this video, and we will be using Gradio Python UI library. So this is a useful UI library to create prototype and quickly create a chatbot like user interface. So for this we need to install Gradio and tabulate to show the tabular data inside chatbot. So let's install it. So next we will be importing Gradio. Then we are closing all the previous Gradio instance if they are running. So in this way, whenever you run this program, it will create only one instance rather than creating multiple instance. Next, we are creating a function called chat with DB, and then we have a function clear chat. Next, we are creating the UI in here. We are using Gradio blocks to create a block, and first we are defining a title. This is a markdown language we are using. So this is title, this is subtitle. Then we are creating the chatbot, and on the next row we are creating a text box for typing our prompt and a submit button, and on the below we are creating a clear chat button. Then we are adding two events for submit button and clear button. So for submit button we are calling chat with DB, and for clear button we are calling that clear chat function that we define in the top. So as an input we are passing message and chatbot. So message is from the text box value, and this is the chatbot where we will be showing all of our response data. So that's why we are telling chatbot and message. Okay, so let's see what we are doing in this chat with DB function. So in here we are passing message and the previous history. So if there is no question, then we will be asking please enter a question, and then what we are doing is we are calling our previous query database with AI function. We are passing the client and the question from the message input field, and if the data is empty we are telling there is no data found otherwise, and if there is a data then we are converting panda data frame to markdown language to render it inside chatbot. And this is the history if there is older history. So what we are doing is first we are appending our question that we type, and then in the assistant role we are appending our answer that is coming from the table, and then we are returning our history. So let's see how it will work. Run demo.launch. So it will launch a instance of that Gradio chatbot. So this is the instance. You can access it from this URL also. Let's open it. So this is another instance running on 77861 port. So let's try some question. Fetch me all details of John and his marks of every subject. So this is a complicated prompt. So let's see. AI will analyze this prompt and generate dynamic SQL query. Then we will be executing those SQL query to the database and returning the data. So as you can see, this is the data related to John. So there are 5 subjects. We have this 5 subject. He is on class 5 and this is the test mark. So this is the test mark, test name. So math 5, physics 5, chemistry 5, biology 5, and this is the marks. So 81, 75. So as you can see, we just create a chatbot which will talk to our database, and we just pass the database schema and its relationship, and now we can talk to our database like we talk to as a AI agent. So this is very useful in data analysis project. And always remember to use read-only database credentials, because sometimes LLM and chatbot can generate malicious SQL queries that could alter the data inside your table or deleting some data. So always remember to use read-only credential for your database, because we are using panda.read SQL in here. So that's why it's safe in here to execute SQL query directly to the database. But if you are using some other methods on a production database, always remember to use read-only database credentials. So like we are fetching the data from the database, we can also update the data in the database. But it is not recommended to fire raw SQL queries to the database directly. In there, we are using a separate concept called tool calling. Generating SQL queries, we will ask our LLM to call a tool instead. What is tool? Tool will be a extra function that may be call a API, and we will be asking LLM model to generate required parameters for it and pass to that API parameter, which will call the database manually. It is far more safe compared to this raw SQL query execution, and we will be seeing in the next video how we can call a tool from the LLM. Thank you for watching, and if you like this video, like this, subscribe to this channel for more GenAI videos like this. In the next video, we will be checking how to call a tool from the LLM. Thank you for watching.